Very warm welcome to everyone. Kia ora. Our third webinar already in a series of webinars, as many of you know who are coming back, returning participants. We have a number of webinars scheduled from now until September actually, and these webinars are part of our booklet that will be published on progressive thinking, 10 possible futures for public and community services. And many of you will know that it's the fourth book in a series again. We have done a couple of books on tax, housing, and the future of work. And of course, you find them all on our website. If you haven't seen them, check them out. They're really exciting. Due to COVID, we couldn't do our regular lunchtime seminars, which we usually do to accompany the releases of our books with people who participated in or contributed to the books. And because we were, we were unable to meet in person, we have decided to do these webinars. And as I said, today is the third one, and we are welcoming Troy today. But before I introduce you, Troy, I'm quickly running through how we are doing the webinar, just to remind everybody. So we'll do a quick introduction, and then our guest will present the chapter. And you are in for a very special treat today. I won't say more, I'll get to that in a minute. Then we'll have a bit of a discussion, and of course we'll invite all of our participants to use the question and answer function. Please, the question and answer function, not the chat function. Post your questions as well, which I will then try to ask on your behalf. And questions that will remain unanswered until the end of the webinar. We often have that because you have so many questions to ask, which is fantastic. Our guest will be able to answer them at a later stage, and we might be able to post them on Facebook or via different means, but we'll let you know how we are going to do that. The webinar also will be available on the Facebook page, so feel free to share it with your colleagues and friends if you thought it was interesting. But let's get to the core. So welcome. Today with me is Troy Baisden, Professor Troy Baisden from the University of Waikato. And Troy is also the president of the New Zealand Association of Scientists and the principal investigator of Te Pūnaha Matatini Centre of Research Excellence. So very warm welcome to you, Troy.
Thank you very much. Kia ora.
You have, welcome. It's a real pleasure. You have written on restoring research for the restoration of well-beings today, and we'll again get to that in a minute. But first of all, you told me on the phone that you are a mentor, that you're dedicated and you're quirky. So these are quite intriguing descriptions. So maybe you'll tell us a little bit about yourself before we get into the contents of your chapter.
Very good. Well, I guess, working from those three words, one thing I really do, and that drives me to be the president of the New Zealand Association of Scientists, is really looking after people. We often have institutions really thinking institutionally in the science system, and New Zealand Association of Scientists and the Public Service Association, PSA, are really institutions that try to look after the people. And of course, I used to be in the PSA and on the PSA National Science Committee when I was in GNS Science up through about 3 years ago. And so that was a wonderful opportunity to get to know the PSA team in Wellington a bit better. It's been great to continue a little bit of a relationship because we work very well together with the New Zealand Association of Scientists. Like all scientists, I think I'm quirky in the sense that I like sort of odd and funny things, and if you get to know the New Zealand Association of Scientists, you'll find that sometimes we have, some of the nation's most prestigious scientific awards, and what's ostensibly a grunge bar or something like that, or some relatively odd music playing in the back of the Royal Society building. And so I felt it's an organization I fit in quite well with. Mm-hmm. Now, what did I say was my last word? Dedicated. And I think that's the important thing here is I'm also dedicated to trying to do the right thing for all these people. And that's really what's driven to me to be try to be a researcher, a scientist, and also now a leading academic as a professor. It's both to look after the environment and look after other people that are doing that. Being dedicated to making sure we get information right and do the best research for the country is one of the most important things there. And one of the things that drove me to put the chapter together the way I did is the opportunity to think about the ideas of restoration, ideas of restoring ecosystems. One thing we think about when we do that is to think about how do we actually understand the function of ecosystems so that we can build back the best possible thing. It may not be what was there originally, but it represents something that's going to be self-sustaining and desirable. It has both natural aesthetics and a number of other good properties. And so what do we want out of the future science system if we have some opportunities to reorganize as a result of the current crisis or crises that we're thinking about?
We are really lucky to have you. I can hear that already, and thank you so much for making yourself available to share some of your knowledge and actually your commitment to what you're doing to science and research in general. I think it's very important. And I think it's very important for our members, of course, as well, because we are talking a lot about evidence-based research, evidence-based policy. So a lot of our members will do their own research, but also will use a lot of research to develop policies and serve our communities here in New Zealand. So I would suggest we'll just get into your chapter. And as I promised, we'll have a special treat today. Troy brought us a video today, and so we'll share that with everyone. And after that, we'll have our usual conversation, and please already use the question and answer function during the video. I think it should work. If not, then definitely after, and we'll have enough time for questions as always. So Troy, the floor is yours.
Okay, thank you very much. So what I'm going to do here is a little bit innovative. I'm not sure it's quite as exciting and wonderful as Andrea made it out to be, but it's basically a video of me that I shot in the same location I am now a little bit earlier, and then added in the graphics that we would normally share over PowerPoint or something like that. So it's just a little more elegant in its presentation. And why would I do something like that? It's all about innovation, because we're thinking quite a bit in universities now about teaching online and trying to make that student experience better. And so I think trying to have videos of around the length that I'm about to show you is probably about right. And then we can actually use Zoom really well for discussion. And so that's sort of what we're going to do today. And I think it's going to resemble a lot of the experience that some lucky students are going to get as we move forward with the current situation under lockdown, or as we come out of it. But we're not going to resume having tens of thousands of people at universities. So here we go.
Awesome.
Let's talk about research. And when we talk about research, it would be ideal to define research. It's actually quite difficult, except that it's similar to the research that almost everybody's done in school or to buy a new product, except there are formal processes, and we're generally looking at research that justifies investment. So it's easier to just move on to the idea that research is useful. And let's think about some of the products of research. One of the obvious ones is a smartphone. And as Max Rashbrook said in the last one of these talks, a number of pieces of what we have in smartphones came out of technology, about a dozen different developments that came out of government-funded R&D across the world over decades. We might also just think for a moment that these were inspired by the ideas from science fiction. Here we have Star Trek, And it's amazing, really. We couldn't have imagined a couple decades ago being able to test individuals for viruses the way that we've been able to. We can even sequence the DNA from an individual case and then determine which part of the world it probably came from by matching it to other sequenced coronavirus genomes. These are amazing examples, and we can also think about climate change, for example, as another, where the increasing carbon dioxide in the atmosphere was first measured in the 1950s. At the time, it was an absolutely phenomenal example where you could see the Earth breathing. And then very quickly after that, you could see this problem with the increase in greenhouse gases. Today, we can see the problem with increasing greenhouse gases and visualize it as climate change in very clever ways. So these, from really cunning visualizations to basic measurements, are all products of research. Do we take them for granted? Sometimes we do, and I think pandemics are one good example. A more familiar one in New Zealand is earthquakes. So if we have to wait a couple decades or more between major earthquakes and have shut down and are not properly funded our monitoring works, we'll find ourselves in a bit of trouble. So how do we fund that, and how do we maintain that funding over a long time? That's sort of what we're talking about today, because we want to think about how to keep going and how to make sure that what we have is properly funded. In New Zealand, we have a lot of science institutions. First of all, we have a lot of Crown Research Institutes at the top of this slide, and then we have quite a number of universities. And there's actually even more independent research organizations. I put only a few at the bottom here. Overall, these organizations are funded in a way that's a little bit unusual globally. There's an imbalance in New Zealand towards what I would call output funding, where the government mainly pays for generating the products of research and not maintaining the research system itself. When we think about the research system, what we're really talking about is three different things. One is producing those products of research. Another is actually maintaining the people in the research system and the knowledge. The third piece is making sure that they're actually able to engage with our society, that they can go out and talk to people, and that people have access to the science through the media and through direct channels. And the scientists actually know what is needed of them. So those are all really important pieces. And as I said, we have an imbalance towards funding the first rather than the second two. And so one thing we could consider in the crisis is that it might help stabilize our system quite a bit more if we fund the latter two pieces more than we have. Another thing we can start to think about is who fronted science in the crisis, and where did they come from? How did they get their degrees? Are we replacing that? And if we take just a couple examples, Professor Juliette Girard's the Prime Minister's Chief Science Advisor and has to be seen as an architect of the nation's response. And she came from the UK, did her degrees top-notch Oxford, protein nanotechnologist, and came up through crop and food research, a CRI, and then University of Canterbury and University of Auckland. We could also think about Sean Hendy. He's a Kiwi, originally from Palmerston North, but did his PhD in Canada and came back on a postdoctoral fellowship to New Zealand. And so what would happen if we didn't have these people? Well, I think that's the challenge we face, is that if we're not training Kiwis and it's difficult to recruit foreigners, or maybe it's not as appropriate because it leaves gaps in our system, then we have a problem. So let's think about what are some of the issues we'd have with the gaps in that sort of a system. The first one is, what if we think about the people in New Zealand that deserve access to the system, including access to be taught and brought up through the system in universities? And if we think about the number of Pākehā in New Zealand that go through universities, there's about 95 students for every professor that fit in that category. Then if we think about Māori, we find that there's about 400 undergraduates for every professor. And it's even worse for Pacifica. So that works out to be roughly 1 in 2,000. Well, that's problematic because that tends to mean that those people don't have access to the system. And in fact, it took Pacifica and Maori academics to point this out to us. So Sariana Nipi and Tara McAllister did this study, and they were able to show that it's a real problem. What they've called it is a leaky pipeline. And so that if we're not bringing people through into the research system, then they won't represent and they won't engage with those parts of our society that may need research the most. More commonly, we might just think about the easiest measure of diversity, gender. And similarly, there's been a study done by Ann Brower and Alex James at the University of Canterbury. And these two women have found that the average female academic is paid less over their career by the average of half a house at typical New Zealand prices. So we obviously have clear diversity problems in our academic system. The good news is we have data and we know it. What can we do about it? Well, let's think about, in a crisis, why this matters. And that helps tell us what we need to do about it. If we think about what happens, what are the issues that we've got to cope with in this crisis, a few of them are the crisis itself, and then all the other things that we might have called a crisis before we had the coronavirus in New Zealand. So those include issues like climate change, fresh water, but they also include issues like housing, infrastructure, health, and particularly health inequality. So if we think about those, and then we think about the fact that as we're dealing with any of those, we might have another crisis. Imagine just in the middle of the coronavirus outbreak.
We're just having a bit of an earthquake here, Ryan. Quite a decent shake here.
And indeed, there could have been. One of the problems that happened during the Japanese Fukushima tsunami, we call it the Fukushima incident because it caused a nuclear incident. And so multiple overlapping crises would not be a good thing. It helps to think about the opportunity to transform our society out the end of this crisis by thinking about the government's budget. The budget came out 2 weeks ago. Most people said it was good. It dealt with employment issues, a number of things, but it clearly was not transformational on many of the issues we're facing. Climate change is often put forward as a top example. So if we think about those issues I just mentioned, we can think about them in terms of Kate Raworth's donut economics model. Just imagine a donut. On the outside of the donut, we can place the limits that society must not exceed on our planet, or we impact our ability to continue living on the planet. So climate change, water pollution, water depletion from water use, toxins, biodiversity loss are all examples there. And on the other side, we can worry about actually not being able to get people out of the hole in the middle of the donut. That area represents basic human development. And if we think about issues that go in there, it's very much housing, food, but also education and access to research, or access to participate in our society at a basic level of development, to be safe. And so we want people to live inside the green space here, which is the safe and just room for humanity. How can we get there? Well, I mentioned the budget, and the government's had a goal to raise investment in research and development to 2% of GDP. That's a good goal, but the problem that we're facing is that the pathway that investment was supposed to take was primarily business research and development as the growing share. And business research and development is not likely to grow as expected if one of the primary mechanisms for getting there was a tax incentive. The other problem we face with that is the idea that business is necessarily the best place to deal with some of the issues that we've got. In many ways it is, but we've also got to get the people into business and train them to get there. And as it currently stands, not only do we have a leaky pipeline, but the good pipeline we do have to train top people trains only a few academics that go through on this academic track. And the data we have here is primarily from 2006. So if we think about the pipeline of scientists and those that go into our government and business research versus those that leave the system but probably know a lot more about science than the rest of society and would be happy to participate and interact with science. We need to produce more, and we need to make sure that they're good. And so we need a system that doesn't produce a leaky pipeline and that keeps people engaged. One of the most important concepts there is making sure that we're doing good science, but also useful science. Those have commonly been separated into concepts called basic and applied science that you may have heard of. And there's the idea that they represent a pipeline from basic to applied, and then on to innovation, the technology that we actually use and that causes our society to improve or grow. And then that leads to more investment in science. That's a model that doesn't entirely make sense at the beginning parts of it, because there's no obvious reason that fundamental attempts at understanding how the world works are different from attempts at creating useful knowledge. In fact, the research I always do aims at both. And so the idea is that instead of having two separate categories, we should think about this as two quadrants or two different axes of activity. And that becomes quite important when we think about the diffusion of innovation model. This is a model that's been around since the 1930s. It came out of the development of agricultural technologies in the US. And what it says basically is that as we develop a new technology, we have an adoption curve. And if we want transformation, we need to get a high level of adoption. And one of the things that has to happen is that you get the original idea itself. Maybe we're developing a smartphone, and 13 years ago, it finally gets to the point where people can use it. There's been a fair amount of development to get there. But imagine how much change there's been in smartphones over the last 13 years. And that's led to nearly everybody having one, from relatively low-cost smartphones to the much more expensive models. But regardless, that process of moving along the curve, and especially the early parts of it, involve understanding what users need. And sometimes that's best done by the users of the phones themselves, in the same way that it's also done in the agricultural space by farmers themselves. And as we move from trying to increase production to reduce environmental impacts, we need researchers that are engaged with that, and we need farmers that are engaged with the researchers, for example. So what that really means in earnest is that we need a research system that's able to engage at a low level with those particular people. And one of the challenges we face is that our research funding likes to focus on big things, and it likes to focus on outputs. And the diffusion of innovation model tells us that pre-selecting outputs and pre-selecting big wins doesn't usually work. So at a basic level, we might want to think about more so-called investigator-led research that is both useful and contributes substantially to understanding that can be shared. Ultimately, as we try to conclude and think about what we can actually do to restore and maintain the diversity and equity in our system that can bring the benefits of research, science, and technology to our whole society, we probably want to think about what we can do to fund the science system properly through this crisis, or fund the research system properly through this crisis. But at the same time, we need to make sure we stabilize it. So that means we don't want to rip it up while we're doing this. That means making money flow through existing channels, supporting existing institutions, and making sure that they have the money that they need to support people. One thing we could ask is whether we can trust our existing institutions to do this. And that raises the point that the easiest way to go forward as we try to increase institutional funding, if that becomes a goal, is to target it at what's needed. And we can do that a lot more quickly than we can develop new funding mechanisms and try to get proposals submitted and then evaluated. And so that's a relatively good way to develop. A second thing that we can do is it's relatively easy to evaluate proposals or applications for early career fellowships, and making sure that we're addressing the leaky pipeline directly by restoring what was once a very healthy postdoctoral fellowship program a little over 10 years ago would be a really important step. So let's look after this system, look after the institutions, and look after the people.
That's fantastic, Troy. Thank you so much.
You're very welcome.
I mean, that was such an important call for the importance of science and research. And you know what I was wondering throughout your presentation was that there are internationally there are so many countries with leaders, and also not just leaders of the country, but also leaders of institutions, of government agencies, who don't seem to put too much importance on science and research anymore. And I was wondering what you would tell those leaders, why it is actually important. What would you say to them to convince them?
Well, I think one of the really useful things is to look at the difference between the countries that have had good and trusting relationships with their experts in this coronavirus crisis versus the countries that have wobbled or distrusted their experts or just changed messages based on sort of political sound bites or daily news cycles. And we probably know roughly which countries we're talking about there. But we could also, for example, see a difference between Australia and New Zealand. We had, I think, incredible leadership and some real excellence in terms of communicating the messages, both from our Prime Minister and from the scientists and advisors that were supporting her. Australia, it was much harder to see that from the Prime Minister over there. I've heard the state premiers were generally quite good. But I think what really got them through to nearly the same place statistically was that their health system was much more able in its state to already undertake the key steps, including contact tracing. And so that's very much an artifact of having had the past technology in place, whereas you sort of saw drama with constant attention on Aisha Verrill's report in New Zealand on improving our contact tracing system and doing that within a month's time, which was done, and I think that's a wonderful thing.
You also talked about the diversity of research for actually, if I understood you correctly, for making research actually useful to people and to communities. And we have one question here around the use of quotas, which I think is quite intriguing, because usually when we talk about quotas, we talk about quotas for women in a kind of a gender sense. So what do you think? Would that help actually to correct the bias towards Pākehā in research and science in New Zealand? Or what other measures would be required to correct that imbalance? We might need to look wider actually than just quotas. That's
right. So quotas is certainly a good question, and it could help. So certainly if I were looking at a large institution level or a national level, and we looked at some data from the PBRF and that reflects the Pacifica and Maori presence in universities, and the same data also contributed to the study on gender equality and pay. So those are areas where at a level it could support quotas. Would it really be useful? I think that to do that, you've got to come down to the level of individual hiring and promotion decisions. And that's where I think it's much better to address the factors that lead to inequality. So do women, for example, get held back because they actually took time off related to child rearing? Or one of the other things I put links to in the chapter is that there's already evidence that women are submitting less papers as a result of the crisis than men in fields where they had been catching up. And so those are things where quotas obviously won't help us. They're not reactive enough. The idea would be to understand what causes the problem now that we do have the data that could support quotas, and use much more proactive measures to help get us where we need to go by basically supporting a higher level of equality, and to think about where we want to end up if we believe that having scientists that are more representative of society is a good thing, in the same way that having better representation, for example, of women on boards or of minorities on corporate boards is a good thing. we can't do it by saying that, oh, we picked the best candidate for the job, and that means that people that actually contributed to their family a little bit more than their job got set a rung behind the ladder at every step along the way to the top. And eventually we ended up with corporate boards or rooms full of national science advisors that were all men or all white men.
It's really a little bit like in health, an area where I do a little bit of research and I guess policy development, where you have a strong need for looking at the social determinants of health. So it's very similar, isn't it? You need to look at the social determinants of researchers or potential researchers and for education for that matter, actually, to start with.
That's right. And we might actually look for the academics that represent, for example, Maori and Pacifica to appear first in certain fields. And so those fields would look relatively good, but they'd still be underrepresented in the overall university system or the overall research system. So we might see them, for example, in health and education first. And that would make sense. But that doesn't mean we should stop building up those areas, because there's probably a long-term backlog to help train more researchers and push them into other areas.
Can I ask you about, I think that links nicely into the conversation about creating diversity among researchers. Your diffusion and innovation model that you mentioned in your chapter, can you explain that a little bit? And can you share with us how that can be actually realized, enacted in real life?
Sure. So actually, if you Google me, there's an idea where we're sort of doing the experiment in real life in New Zealand, where I wrote an article for The Conversation and also in Stuff, it's in the Climate Explained series, asking whether regenerative agriculture, as it continues to innovate, can help us farm more sustainably, so less greenhouse gases and less impacts on water, for example. And well, how exactly would that work? And so the fascinating challenge is that there is actually no definition for regenerative agriculture that really works in New Zealand as yet. And so it's an open slate. And we could, for example, have the new large Maori farms that have come out of treaty settlements doing things in a way that is really innovative at scale. We could have Landcorp doing that. We could have regular Kiwi farmers that are third, fourth, fifth generation farmers, all participating in this along with researchers. And so the key thing would be, right now there's no definition, and we're right at the bottom of the adoption curve of regenerative in New Zealand. There's probably only a few farms that will definitely want to call themselves regenerative, whatever that means. It's kind of like the new organic, right? And what happens is we define it and then actually start looking at one area of the country, and suddenly half the farms want to call themselves regenerative. And then one of the things that means is that you can have a supply chain from regenerative farms to consumers. And then the consumer preference starts to kick in and increasing the value of the products to match what consumers want. And so those are all the steps that involve multiple steps of research, but also multiple steps of innovation by the people potentially running those farms, and maybe making products that aren't directly the commodity itself, but perhaps a food product or a processed product that's partway to what you would put on the table.
So it's really about the connection between the researcher and local communities, right?
Yeah, it's the researcher, and ultimately we in the research system refer to research users and also to stakeholders. And so I think the key thing is they've always been there, but the other side of it is that when we try to deal with getting real transformation, we're also wanting to think about moving from major industry groups that often want to direct things incrementally to getting really sort of quirky or innovative people that are out there, and their neighbors might actually consider them a little bit odd to be involved in this innovation space and do things that one day we're suddenly proud of, sort of the world's fastest Indian kind of stuff, but on a commercial scale, if you know what I mean. Of course, the world's fastest Indian is the guy who built that fast motorbike down in Invercargill, right?
Fantastic, thanks. We actually have another really interesting question about the importance of local, regional, and of course central government in research, and the perceived disconnect between local government and Crown research institutes, and that actually hinders, you know, the best possible research outcomes, I suppose. So what's your take on that? Do you have any suggestions how that can be improved?
Yeah, I mean, I do, and I think it fits with the model of what I'm suggesting, is that the problem there is the cost of accessing research from CRIs. So there's two things going on there. There's the either get a large project funded with an output-based proposal that central government funds, or mostly ask research users to pay for their own research. And sometimes you can combine these two streams and leverage them. And that's what CRIs are designed to do really well. So they're really unusual globally because they're combining the research function with a commercial function and putting the two together. So that's why actually our existing institutions are potentially really useful. But the problem is they're often wanting to charge too much for data or research for our users to be able to afford it. And that's why putting more money back into making sure that the system is stable and making sure that people have access to it. It might be the regional councils, it might be community farming groups that interact with the regional council. It might be iwi that want to understand the impacts of their own farms on water, or the interactions between the community farming group and water within the rohe of the iwi or hapu. And so all those things require potential input and interactions with researchers who are well supported to have those conversations and really take the time for them. So the question becomes, how do we invest in that? So we may need to maintain the knowledge and expertise, and we need to actually make it accessible to people.
Yeah, you're highlighting the importance of funding, and it's obviously always a very crucial aspect to generating the best possible results and, high quality services for the public service, for instance, good working conditions that are, contributing to the best possible standards of research and innovation. And I'm wondering, what other aspects there are in addition to funding, which is crucial, but that can foster, those that high quality research and science that is useful and usable, I think, to use your words, which I really liked. What do you think?
Yeah, well, it might be useful for me just to explain that useful versus usable distinction, wouldn't it?
Yes, please. Yeah, go ahead.
And I think that's one of the other ones that's really interesting when we think about it from the standpoint of institutions that are really engaging with their public, if you will, versus institutions that are presenting good proposals that get funded and then produce outputs, is that it's easy to pitch outputs as being usable. That means that the information looks like it's at a level that's understandable, but it's not necessarily targeted to really make that difference, or to, the thing I would really say today is that if we want transformation, that's got to get us going along that curve so that we can actually stack up a number of innovations that actually eventually produces something that works really well. And that's a result of a number of small changes that all add up to one big transformation usually. So that difference between just being usable, meaning the information sort of understandable and it makes sense to the audience, versus useful. It's targeted to the part of the system that's really going to make a difference. Those are, I think, really important steps. Now, did that answer the question?
Sorry?
Did that answer the question fully? I think I might have forgotten the first half of the question while I was along the way.
The question was if there are other aspects in addition to funding that are important or necessary or could be put in place to support that usable and useful research.
Yeah, and actually another good one. So almost everything, we actually do worry about funding in New Zealand. We're not a rich country in some ways, particularly with regard to the level of research we have funded. We're still below that 2% level. that I cited. And one of the things that I think is really worth highlighting is data. You know, having data that's accessible, that's useful and usable, and in a format that people can work with is really important. And sometimes that's one of the other things that our research institutions aren't good at providing. One of the reasons for that can just be because data provision wasn't well funded in the past. And so certainly one of the things I've been involved with and that I inherited in the role that I've got here is having user portals that are good ways for people to get access to data. That's really interesting when we think about what government could fund to support research institutions and to support benefits back out into the economy. Is just making data accessible can actually be a lot of work. It needs documentation. It often needs an interface built. And in some cases, institutions are holding on to that data because they think they need to charge people for it, and they're worried they're going to run out of money if they don't. And so that's actually one way that the government can fund something that really supports people out there, making access to government data. And that includes more access, for example, to regional council data.
Our time is nearly up, but I still want to get in a few questions from our audience. One is around the challenges or sometimes the difficulties between, I guess, you know, communication between scientists and entrepreneurs or the private sector. And I think it would be no different to the public sector either. And, you know, the participant is suggesting that, you know, it's all about partnership, about working together, seeing that bigger picture from both sides, and I guess combining the strengths that everybody brings to the table. Would you agree with that? And how would you solve those challenges when they arise in terms of language and, you know, backgrounds and expertise?
Yeah, so it's interesting. As a scientist, I work largely with government, you know, both regional councils and central government to understand contributions to environmental science, and then around the edges with people that have that industry environment interaction around the environment. So I do less with sort of technological development, but I certainly agree with the problem. And I think that the answer is really building experience for the scientists, trying to break what they're saying down into words that make sense to normal people. When I first met my partner, she couldn't believe that I could sit down at lunch with a bunch of scientists and talk in language that she just couldn't understand, except she knew it was English. And I think that's the experience that a lot of people have with scientists, right? And they sort of enjoy those quirky aspects of it. And that makes it worse for people that don't understand. And the reality of it is that, you know, in some ways, for example, farming is the same. You've got to understand the lingo, but it's communication and you've got to work at it. That's the bottom line. And it's easy to say, it's harder to do, but the biggest thing it takes is time.
Thank you so much. I think we probably have to stop here. We have a lot of other really interesting questions, but you offered as well to answer some of them at a later stage. So we'll do that and get in touch with our participants about how we are going to answer them. So thank you all for them. I will just say that our next webinar is, let me just double check this, on the 10th of June, and we are going to talk to Peter McKinley about local government and well-being, which shall be a very interesting webinar. So if you have enjoyed this, and my apologies for not getting through all of your questions, but as I said, we will make some answers to them available. Thank you very much for coming along again, for participating, and do feel free to share Troy's chapter with friends and colleagues on your social media, and of course the webinar, which will be available on Facebook as well. And I think, you know, I'm getting to the end, and we'll say thank you and stay well.
Thank you all very much from my end as well. And sorry, I might be a little bit long-winded in getting through your wonderful questions. They're very interesting.